Okay, this is Nicholas Bishop's and mine, Darren Cobian's recording for lab 4, which is edge triggered and SysTick interrupts. And before I go into the debugger and the watch screen as well as memory, first I will talk about the code a bit. So here we have the predefines, which are basically the define statements that are going to be used later by port F when we're initializing them. These are just the function prototypes where all I pretty much changed here was adding the parameters to the prototypes. So I added void, unsigned long period, and here we're going to pass in basically for 16 megahertz, we'd pass in the integer 160,000 because that would allow the that would allow the delay to be 0.1 seconds. And then we have void for these. Here we initialize the rising edges and counts variables. Counts is just to track in memory, and rising edges is to track how many times we actually press switch 2, which is PF0. Finally, in main, so these came with the code. Basically, all of this came with the code that was given to us. The only thing I changed was adding 160,000 here for a 16 megahertz system for 0.1 second delay. I would change this to 800,000 for my Tiva Launchpad, which is 80 megahertz, which would also make that 0.1 seconds. Here, basically all this does is enable the red LED it enables the red LED that's on our Tiva Launchpad. Then in the while loop we have our interrupt. So here we have our initializations of the different things that we're using here. So port F LED init just initializes port F 1 through 3, which is the onboard LEDs, and this is friendly. SysTick init. That's just basically the initialization of the delay. So as I mentioned, it'll be 0.1 seconds on a 16 megahertz system with the number that I passed in above in main. Here in edge counter, essentially I just made it so that instead of, so before this was PF4, but our lab requires PF0 to be the interrupt. So we just switched it to be a initialization of PF0 or switch 2. Pretty simple there. And then here to make this, basically the only change I made here in this is the actual edge counter, was this line here. Essentially, I just made it a rising event. Before it was a falling event with a tilde in front of here, basically. That would make it a falling event. So, oh, well, down here, actually, I acknowledge the switch. So that's switch 2, rising edge increments every time I press the switch. And then here, I shut off the red LED, turn on the blue LED, and in memory, you'll be able to track the counter for how many times it actually does that. Additionally, if this line here was not done, then the LED on board would look pink because it's essentially switching so fast on an 80 megahertz system that it combines the colors together. So that's why I'm switching the variable above when I'm actually showcasing this on the Tiva Launchpad itself. So now I'll go actually to the debugger here, turn that on, and this is the board we're going to, the screen we're going to use here. Essentially, we're going to click run, and you'll see that I'll zoom in, but you'll see that the LEDs are going to switch from blue to red, and then I'll actually show the switch interrupt essentially. So here we can see so it switches from red to blue in 0.1 seconds. It's pretty hard to track, I know, but it does. There's some lag there, some lagature. And then, so down here is the variable that we're tracking our interrupts with. So it's rising edges, starting at 0, of course, because we have no interrupts yet. So once I click switch 2, I'll actually back up a little bit. You'll see this light up slightly green. So let's see, switch 2, there it goes. It's a rising edge, so that's the interrupt. When I actually click it, the falling event does nothing. So then if I keep doing that, it'll keep going. Remember, falling event does nothing because this is a rising event system. And yeah, so I'll just go up to 10, I guess. There you go, A. And finally, I guess, before I actually show it on board, I'll quickly show the memory in which we can actually see count increment pretty quickly. Again, this is 0.1 seconds, so it'll continuously increment until I actually stop the system itself. So that's why it's going so fast, and this is where we see it in memory. And that's the screenshot that's going to be included in the lab turn-in. So now I'll stop the simulator. I'll reset this, and then I'll stop the simulator, actually stop the simulator, and of course it chooses now to lag. There it goes. Okay, so now before I show it on board, what I want to do is change this to, actually I'll leave it on 160,000, I'll build it, load it, and you'll see that it's pink, and then I'll show it on an 80 megahertz, which this would actually be 800,000, so it would actually be 1.1 seconds. So load, build, load, and down here, if I click reset, you see it's pink, and you could kind of tell that it is switching, but it's really fast. It's almost, you can't tell unless it's on camera. So that's on 160,000, which is on a 60 megahertz system technically. So if I just make this 800,000, my turn in will actually be 160,000 because that's what the lab requires. But just to actually show this on my board, so I'll build this, and then I will load it, and then I'll reset it, and you can actually see red and blue now in 0.1 seconds. Maybe it still looks slightly pinkish, but I could show you that it is flipping between red and blue in 0.1 seconds. It's just really fast. And yeah, so now I guess before I finish this, I'll just switch this back to 160,000 and actually get this ready to submit. There you go.